In 1984, the National Electrical Code, or NEC, did not permit the use of 10-2 wire with a background for dryer outlets. The code mandated the use of 10-3 wire with a ground wire for such installations. The difference between 10-2 and 10-3 wire is significant in terms of functionality and safety. 10-2 wire consists of 2 current-carrying conductors and a bare ground wire, while 10-3 wire includes 3 current-carrying conductors and a ground wire. Dryers typically require a 240 volts power supply for the heating element and a 120 volts power supply for the motor and controls. This necessitates the use of 3 current-carrying conductors. The 10-3 wire provides the necessary conductors for both the 240 volts and 120 volt circuits, whereas the 10-2 wire only provides the 240 volt circuit, lacking the neutral conductor required for the 120 volt circuit. The ground wire serves as a safety measure, providing a path for fault current to return to the source, tripping the circuit breaker and preventing electrical shock. The presence of a dedicated neutral conductor in the 10-3 wire is crucial for proper operation of the dryer. Without it, the 120 volts components would not function correctly. In the context of electrical wiring, understanding the role of each conductor is paramount. The hot wires, typically black and red, carry the electrical current from the power source to the appliance. The neutral wire, usually white, provides a return path for the current, completing the circuit. The ground wire, either bare or green, is a safety conductor that connects the appliance's metal parts to the grounding system of the electrical panel. This grounding system ensures that any fault current is safely diverted, minimizing the risk of electrical shock. The National Electrical Code sets the standards for safe electrical installations. It is updated every 3 years to reflect advancements in technology and address emerging safety concerns. Adherence to the NEC is essential for ensuring the safety of electrical systems and protecting people from electrical hazards. When working with electrical wiring, it is important to consult the latest edition of the NEC and follow all applicable regulations. If you are unsure about any aspect of electrical work, it is best to consult a qualified electrician. Improper wiring can lead to electrical fires, shocks, and other hazards. The NEC provides specific requirements for the type and size of wire to be used for different applications. These requirements are based on the current carrying capacity of the wire, the voltage of the circuit, and the environmental conditions. Using the correct type and size of wire is crucial for ensuring the safe and reliable operation of electrical systems. The NEC also specifies the methods for installing and connecting electrical wiring. These methods are designed to prevent damage to the wiring and ensure that connections are secure and reliable. Following proper installation techniques is essential for preventing electrical problems and maintaining the integrity of the electrical system. In the case of dryer outlets, the NEC requires the use of a 4-wire system for new installations. This system includes 2 hot wires, a neutral wire, and a ground wire. The 4-wire system provides a more reliable and safer grounding path compared to the older 3-wire system. The 4-wire system separates the neutral and ground conductors, reducing the risk of neutral current flowing through the grounding path. This helps to prevent voltage in the appliance chassis and minimize the risk of electrical shock. When replacing an old 3-wire dryer outlet with a new 4-wire outlet, it is important to follow the NEC guidelines for proper wiring and grounding. This typically involves running a new 4-wire cable from the electrical panel to the outlet location. The NEC also provides requirements for the size and type of conduit to be used for electrical wiring. Conduit is a protective tube that encloses electrical wires, providing physical protection and preventing damage. The size of the conduit is determined by the number and size of the wires it contains. The type of conduit is determined by the environmental conditions and the type of wiring being used. Common types of conduit include rigid metal conduit, intermediate metal conduit, electrical metallic tubing, and flexible metal conduit. Each type of conduit has its own advantages and disadvantages in terms of cost, ease of installation, and level of protection. The NEC also addresses the issue of overcurrent protection. Overcurrent protection devices, such as circuit breakers and fuses, are designed to protect electrical circuits from excessive current flow. These devices are rated to interrupt the circuit when the current exceeds a certain level, preventing damage to the wiring and equipment. The NEC specifies the size and type of overcurrent protection device to be used for different circuits. The rating of the overcurrent protection device should be matched to the current carrying capacity of the wire. Using an overcurrent protection device that is too large can allow excessive current to flow, potentially causing a fire or other damage. The NEC also provides guidelines for the installation of electrical boxes. Electrical boxes are used to enclose and protect electrical connections. They provide a safe and secure location for splicing wires and mounting electrical devices. The NEC specifies the size and type of electrical box to be used for different applications. The size of the box is determined by the number and size of the wires it contains. The type of box is determined by the environmental conditions and the type of wiring being used. Common types of electrical boxes include metal boxes, plastic boxes, and weatherproof boxes. Each type of box has its own advantages and disadvantages in terms of cost, ease of installation, and level of protection. When working with electrical wiring, it is important to follow safe work practices. Always turn off the power to the circuit before working on it. Use insulated tools and wear appropriate personal protective equipment, such as safety glasses and gloves. Never work on electrical wiring in wet or damp conditions. If you are unsure about any aspect of electrical work, consult a qualified electrician. Electrical safety is paramount, and it is always better to be safe than sorry. The NEC also addresses the issue of grounding electrode systems. A grounding electrode system is a network of interconnected grounding electrodes that provide a path for fault current to return to the source. The grounding electrode system is typically connected to the metal water pipe, the metal frame of the building, and a ground rod or ground plate buried in the earth. The purpose of the grounding electrode system is to ensure that all metal parts of the electrical system are at the same potential, minimizing the risk of electrical shock. The NEC specifies the requirements for the size and type of grounding electrodes to be used for different applications. The size of the grounding electrode is determined by the size of the service entrance conductors. The type of grounding electrode is determined by the soil conditions and the availability of other grounding electrodes. The NEC also provides guidelines for the installation of ground fault circuit interrupters, or GFCIs. GFCIs are devices that detect ground faults and interrupt the circuit, preventing electrical shock. GFCIs are required in certain locations, such as bathrooms, kitchens, and outdoor areas, where there is a higher risk of electrical shock. GFCIs work by monitoring the current flowing through the hot and neutral conductors. If there is a difference in current, it indicates that some current is leaking to ground. The GFCI will then trip the circuit, cutting off the power and preventing electrical shock. The NEC also addresses the issue of surge protection. Surge protection devices, or SPDs, are designed to protect electrical equipment from voltage surges such as those caused by lightning or power line disturbances. SPD work by diverting the surge current to ground, preventing it from damaging sensitive electronic equipment. The NEC recommends the use of a SPD for sensitive electronic equipment, such as computers, televisions, and audio equipment. SPD are available in a variety of types and sizes, and they can be installed at the service entrance, at branch panels, or at individual outlets. The NEC also provides guidelines for the installation of smoke detectors. Smoke detectors are devices that detect smoke and sound an alarm, alerting occupants to a fire. Smoke detectors are required in all bedrooms and on each level of a dwelling unit. The NEC specifies the requirements for the location and installation of smoke detectors. Smoke detectors should be installed on the ceiling or high on the wall, away from corners and obstructions. They should be tested regularly to ensure that they are functioning properly. The NEC also addresses the issue of carbon monoxide detectors. Carbon monoxide detectors are devices that detect carbon monoxide, a colorless, odorless gas that can be deadly. Carbon monoxide is produced by the incomplete combustion of fuels such as natural gas, propane, and gasoline. Carbon monoxide detectors are required in dwelling units that have fuel-burning appliances or an attached garage. The NEC specifies the requirements for the location and installation of carbon monoxide detectors. Carbon monoxide detectors should be installed on each level of the dwelling unit and near sleeping areas. They should be tested regularly to ensure that they are functioning properly. The National Electrical Code is a comprehensive set of standards that covers all aspects of electrical installations. It is essential for ensuring the safety of electrical systems and protecting people from electrical hazards. When working with electrical wiring, it is important to consult the latest edition of the NEC and follow all applicable regulations. If you are unsure about any aspect of electrical work, it is best to consult a qualified electrician. Improper wiring can lead to electrical fires, shocks, and other hazards. Electrical safety should always be a top priority.